Hey Tree Class, this is Mr. Blevins, and we're going to go into our last section, which is conic sections. So what are the conic sections? Well, this is a 3D rendering of a cone in 3 dimensions. And the definition of a cone in 3 dimensions is this equation up here, z squared equals x squared plus y squared. If I take that away, you can see it goes away. So this is a cone in 3 dimensions, and it's a cone sitting on top of another cone. And you're getting to see a lot more of the upper cone than the lower cone, but there is this symmetry. There's one above and one below because we're squaring z. Okay, so we could have had a positive or a negative. So that's why we're seeing the cone on the top and the bottom. Alright, and then what I'm going to do is I've got this plane right here. This z equals ay plus b. This is a plane. That's the blue plane that you see right there. And I can control the inclination of this plane. So like right now it's just the xy plane. So this is the xy plane, and then we come out of the plane with z coordinates. But if I change the values of a and b here, the plane rotates out of the xy plane. So you can see it's rotating out of the xy plane as I change that. And b controls just a vertical shift of the entire plane. So I can make this be the xy plane. Let me get it back to 0. And then if I just manually type in 0 because it's not cooperating. And then if I adjust b, I could just shift it up and down. Alright, and I intersect the cones. You can see the little black curve is the intersection of these cones. Now, if all I do is just shift up and down, you can see that intersection currently between the cone and the blue plane is a circle. So that black curve we see is a circle. Again, if I take this away, we can see circles form of varying size along that plane. Okay, now what's going to happen though? I'm going to go back to 0. Actually, a circle is a conic section. But what are these conic sections? These conic sections, they're just cross sections of this plane and the cone. So think of the cone being like Play-Doh, made out of Play-Doh, and the blue is just some type of a knife or something that you're going to cut the Play-Doh with. And the conic sections are cross sections of cones. Of these cones, or what we call conics. They're cross sections of the plane and the cone. Alright. The thing is though, we're not just going to lift the plane up like we are here, parallel to the xy plane. We're also going to adjust the angle that we cut the cone. So I'm going to come here to a side view, and you can see as I shift A, let me get a side view with the right orientation, positives to the right, negatives to the left. If I make the angle of inclination positive, we start to rotate off of that positive x-axis. So we're rotating, well, positive y-axis in this case. We're rotating, and we are not quite up to the side of the cone yet. Okay, so when I'm a little bit less than the angle that I've rotated, which is down here from the green up to the blue, when I've rotated a little bit less than the angle from the green up to the red, the side of the cone, watch what happens with those cross sections. When I lift the plane up now with B, I want you to see how these things intersect. So they're intersecting now, but the intersection that we're seeing now is an oval shape, or what we call an ellipse. So I'm going to take the conic away, and you can see as I change B that we get an ellipse of different shapes. It's not circular anymore like it was when that angle of inclination was 0. At 0 we got nice pretty circles. But now that we've rotated a little bit, they are elliptical. Okay, and if I dip down below to that lower conic, let me show you that I'm going down to the lower conic now. Alright, still the same thing. It's just they are down below the XY plane. So we get ellipses of varying sizes when we rotate off the XY plane, but not by as much as the angle of inclination is not as much as the side of the cone. Now I'm going to go up directly to the side of the cone. So I'm going to rotate this up until I just touch barely the side of the cone. Okay, so I'm touching the side of the cone now. So the angle that I've rotated now is exactly the same angle as the side of the cone. And now I'm going to lift the plane. And what shapes do you envision that we're going to create here with these cross sections? Oh, and let me make this, because notice when A is equal to 1, these curves that represent the cross section, we divide by 0. So let me do something like 0.001, just so we can actually see it. But now I have, if you can tell what those are parabola. So let me take that away, and again, we see it more clearly now. I have parabola, and if I dip down below where I make my intersection with the cone, the intersection now is down in the lower cone, I get a parabola down that's opening, what we're used to, opening downward. So we get a whole family of parabolas when we do those cross sections at an angle of inclination that's exactly equal to the angle of inclination of the side of the cone. So again, what I'm doing, if you look there, I'm just moving up and down parallel to the inclination of the cone, just intersecting at an intersection parallel to the edge of the cone, and so it's intersecting in a parabolic shape because of the roundness on the inside of the cone. Alright, and then one more, if I go a little bit beyond this, let me get B back down to 0. When I go back beyond that angle of inclination, we get something that a lot of folks who are taking trig for the first time haven't seen this before, and this is what we call a hyperbola. You can see now I'm intersecting the upper cone, and now I'm also intersecting the lower cone. This is the first time I've intersected both at the same time. Looks like a couple of absolute value functions right now when we haven't shifted up. But as soon as I shift up above or below, these become what are known as hyperbola. So I have this kind of parabolic looking shape almost above, and then below it's not really a parabola because it has these asymptotes along the side. But I also have one below, and the same thing will happen if I shift downwards. Just go back in the other direction. Alright, so let me take the cone away, and we can see, let me also shift this down a little bit so we can see more of the lower one. We can see those hyperbola form. Alright, so there's the conics, hyperbola, parabola. That's actually a little bit bigger than 1. Let me do again. 1. There's parabola. And then when we go below that, we end up with the ellipses. And then finally, when A is 0, when we don't rotate, when it's just the XY plane that we're lifting up and down, we get circles of varying size. Okay, so those are the conic sections, and we're going to go over them in detail one by one, starting with the ellipse.